Hi everybody! Our learning target today is I can apply the segment addition rule. Don't forget to fill in your name, the class, and the date. Our essential question is, how do I measure a segment with missing information? Down below, we see a ruler. And a ruler is a tool to measure a segment. We see we have long lines, and those are centimeters. And we see we have short lines, and those are units called millimeters. Here's our first problem. The distance between A and B is what? So here we see point A, it's lined up on top of the 4, and point B lined up on top of the 7. And the shortest distance between 2 points is a straight line. And so I'm just going to count. Between 4 and 5 is 1, 2, 3. So the distance between A and B is 3 units, and since we're measuring the long line, it would be centimeters, 3 centimeters. What we just did is one of our rules. Rule number 6 is also known as the ruler postulate, which says every point on a line can be paired with a unique real number. Great. And really what's happening there is we can eyeball the length just like we did. But if we know that A is 4 and B is 7, we can subtract the range. So this AB, the measure of AB, is the absolute value. Those are absolute value bars. Absolute value of B is 7 minus A, or 4, and we can work that out. So the absolute value of 7 minus 4 is 3, is just 3, because absolute value is just measuring distance, and distance can never be negative. It's always positive. We can measure left to right and right to left. So A is 4 minus 7. The absolute value of 4 minus 7 is the absolute value of negative 3, and the absolute value of negative 3 is just 3. So whether we measure from left to right or right to left, we get the same distance, and distance is always positive. So here we're reporting that the measure of AB is 3. You might notice something different. You might notice that we're missing the segment line on top. So this is red. The length of segment AB is 3. This is important. So if we're measuring, we're not going to put the symbol on top. So we use AB with the segment on top, like a little hat, is a name. And AB with no line on top is a length, something we measured. Great. Let's practice. So example number 1, find the length of segment CD and the length of segment EF. All right, let's start with DC first. So I've got to find D. They tell us it's 4.5 and C is 2. So the length between C and D is 1, 2.5. So the length of CD, we're actually measuring it, is 2.5. Let's find our next segment, E and F. 1, 2, 3. So EF is 3. It's interesting because they look so close to being the same length, but they're really not, so we have to measure it. But we could be in a situation where we have segments that are the same lengths. So I'm going to draw, to the best of my ability right now, two segments that I'm going to say are the same length. Now we know with segments we have to name the endpoint, so this will be segment WX and segment YZ. We drew them to be congruent, so to show that they're congruent, I'm going to put these two vertical lines, one on each segment, to show that these two segments are the same length. And we call this picture congruent segments. Congruent segments have the same length. And we write that with symbols. Since we're naming and not measuring, it's going to be segment WX congruent to, the symbol is an equal sign with a curve on top. So congruent, the symbol is an equal sign with a curve on top, to segment YZ. There's one more way you could see congruent segments, and that's if the two are connected together. So I'm going to make a longer segment, and in the middle, I'm going to put a dot, a point. I'll name that point M because it's in the middle, and the two endpoints I'll name A and B. The point in the middle we call a midpoint. So the midpoint of a segment bisects the segment into two congruent parts. So bisect is a sneaky vocabulary word. It just means divides into two equal parts. AM is congruent to segment MB. Great. Our learning target is I can apply the segment addition rule. And here's what we can do. Here's rule number 7. It's called the segment addition postulate. So if points A, B, and C are on the same line with B between A and C, I'm going to draw that out. If I've got a line and B is somewhere in between, I don't know if it's in the middle or not. We cannot make that assumption. Then it says that AB plus BC is equal to AC. So this is just saying part plus part equals whole. Let's practice. So point B is between A and C. Let me draw a picture. And okay, so B is between A and C. and they give us some information. They're telling us that AC is 14, so I'm going to say that between A and C is 14 units, and between B and C we have 11.4, and we want to find the length of AB. So knowing what we have up front, above, so we've got AB plus BC, using our rule, equals AC. But we know what BC is. BC is 11.4. And we also know what AC is, that's 14. So we can bring the rest down and solve for what we don't know. Okay, to get AB all by itself, I can just subtract 11.4 from both sides, leaving me with just AB equals 14 minus 11.4. That gives me 2.6. Great. All right, let's try one that has some algebra in it. So in problem B, it says S is between R and T. Find RT. We don't know that S is in the middle. It's not a midpoint. So we're going to have to take RS plus ST is going to be equal to the whole thing, RT. And we'll plug in what we know. RS is 2x plus 7. ST is 28. And RT will substitute as 4x. All right, if we look at our parentheses, there's no negatives in front of it, no numbers, so there's no distributing. So we can just remove the parentheses and solve for x. The first thing I can see to do is to add 7 plus 28. And 7 plus 28 gives me 35, bringing down 2x and 4x. Great. I see I have x's on both sides, and 2x is smaller than 4x, so I'm going to take the opposite of the smaller value, and it cancels to 0, leaving me with just 35 equals 2x. Almost have x by itself. Right now it is right next to 2, so we can divide by 2. And 2 divided by 2 gives us 1, so we cancel to 1. And half of 35 is 17.5. Let's see if we answered the question. We need to find RT. Okay, we didn't answer the question, so R to T is 4x. And we know what x is. That's 17.5. So RT equals 70. Wonderful. Our last example, here's a new vocabulary word using midpoints. So midpoint means the middle. To find the length of C. C is the midpoint of AB, so C is in the middle. And if we go back to our notes, we know when we have a midpoint, the left side is the same length as the right side. This is really cool because we can just set the left side equal to the right side. So if I say that the left side is, so we can take AC and set that equal to CB. And we're talking about the length, so I don't need the line on top. I know that AC is 2x plus 1, and CB is 3x minus 4. Looking in front, I don't see any negatives or any positives, so I can just drop my parentheses and write 2x plus 1 equals 3x minus 4, and see what I have. I have variables on both sides and numbers on both sides. So I'm going to find the smallest number, and that's -4. Negatives are always smaller than positives. And if I add 4 to both sides, let's see what we have. Bring the 2x down. 1 plus 4 is 5. And bring the 3x down. Great. I still have x's on both sides, and 2x is smaller than 3x. So if I subtract 2x from both sides, I have 5 equals x. Awesome! Let's see if we answered the question. Find AC, CB, and AX. Nope, we just found what x is. So let's look at the first one. Let's look at the length of AC. AC is 2 times x plus 1. And we know that x is 5. So if we work our PEMDAS, 2 times 5 is 10, plus 1 equals 11. So we can say that AC equals 11. Great. And here's the cool part. I know that the length of AC is the same as CB. So CB also has to be 11. Cool. And if I take the length of AB equals 11 plus 11, which gives me 22. Let me just rewrite that. And we are good. All right, you try. See you in class.